let's look at logarithmic differentiations. So the first rule I usually take, well, the first step I usually take in these types of problem is rewriting my, square roots or stuff of that, cosine squared, tangent squared, whatever, as powers. So I'll do that. That's the first thing I'll do. So y is going to equal ln of 3 times 5x plus 4 to the 1/2 power, right? Multiply by, look how I'm going to rewrite this, sine of x cubed. Very important that you do that because sometimes you'll forget and it will make your life a misery, right? Over again, x to the 6 multiplied by x minus 5 to the 4th. Right. So the second rule, after you've rewritten your powers, the second rule I do is distribute my natural log to everything and make them products and sums. Well, not products, but make them sum and differences. So remember, anything that's on the top is usually addition, and anything on the bottom usually subtract. So again, the ln of 3, distribute that to my 3, right? But since these are multiplying, I'm going to put a plus right here. This is going to be ln of 5x plus 4 raised to the 1/2, yes, plus again ln of sine x raised to the 3rd power. I'm going to subtract that from ln of x to the 6 minus ln of x minus 5 to the 4th power. So now that I have it in sums and differences, remember the log rule says I could just bring down my exponents. So y is equal to natural log of 3 plus 1/2 ln of 5x plus 4, right, plus 3 ln of sine of x, right, minus 6 ln of x, minus 4 ln of x minus 5, right? So now this looks like something we could work with. All right, so y prime now will be, well, the natural log of 3, that is just a constant, so this is actually 0. So natural log, derivative of natural log of 3 is 0, all right, plus, well, 1 stays on the top. Derivative, anytime I see a natural log, I'm going to draw a fraction bar. Again, u goes on the bottom, so this will be 5x plus 4, which is my u, and then the derivative of u prime of u goes on the top. So again, that's just 5, right? Because derivative of 4 is 0, derivative of x is just 1. So you live with 5 for that, right? But, right, remember this is 1/2 here, so the 1/2 is being multiplied. So basically you have a 2 down here, and you have a 1 up here being multiplied, right? And we could clean up that in a second, right? So we're going to plus that by, again, it is helpful to see that this is actually 3 over 1. So I'm going to have a 3 on top here, right? Again, fraction bar, u goes on the bottom, which is just plain old sine of x, right? Derivative of that goes on the top. So derivative of sine of x is just cosine of x, right? Again, I'm going to minus that by 6. These are being multiplied. We could just clean that up in a minute, right? So again, this is also 6 over 1. So I'm going to put my 6 here. The natural log of ln of x, that is helpful to remember, is just 1 over x. Just 1 over x, right? So knowing that was just 1 over x, we'll clean that up in a minute. And again, minus 4, helpful to know that this is 4 over 1. So I'm going to have my 4 here, all right? My u will go on the bottom, which is just x minus 5. My u prime will go on the top, which is just 1, because derivative of x minus 1 is just 1. Yes? So now that we have all our stuff, we can just go ahead and clean this up. All right? So my y prime will be 5 over 2 5x plus 4, all right, plus 3 cosine of x divided by sine of x, all right, minus 6 over x, all right, minus 4 over x minus 5. All right, and this will be my answer. You could simplify a little bit more. This could, possibly go cosine over sine of x is just cotangent. So y prime will be 5 over 2, 5x plus 4 plus 3 cotangent of x, right? Minus 6 over x minus 4, x minus 5. And that will be a feasible answer of my derivative. You could also change y prime to dy dx. I just did y prime here, but very important that you do dy dx. It will make sense. But it doesn't matter. Notation doesn't matter. How about this one? So how are we going to use logarithmic differentiation for this? It didn't specify ln. So in this case, what you want to do, you want to take the natural log of both sides because they didn't tell you. Usually with these type of problems, they'll say, okay, well, use logarithmic differentiation. Well, again, to use log differentiation, you got to have some log in the equation, right? There's no log here, yes. So we got to take natural log of both sides. So ln of y will be ln of 7x plus 1 squared tangent of x, right? That is all being divided by 3, 2x plus 1, x minus 5. Now we could go ahead and use our logarithmic differentiation. However, right? This is now implicit because now we have, two variables on, Now we have a variable, now we have y over here and we have x over here. So we're solving for dy dx in this case. Right. And the first one also we were solving for dy dx, but it was more explicit, so that's why I used y prime. But for here, I'm going to use my dy dx. Right. So now here's what I want to do. Again, I'm going to take the first step and rewrite my powers. All right. I'm going to put my powers in the appropriate place. So ln of y will be ln of 7x plus 1 squared tangent of x, and that will be all divided by 2x plus 1 to the 1/3 power, because that is a cube root, times x minus 5 to the 4th. Now the third step is just distributing my log over here to all these, making them sums and differences. So ln of y will be ln, and I'm just going to do everything in one. I'm going to bring down my powers also, right? So remember, once you take the natural log, right, once you apply those natural logs to these products, you could bring down their exponents. So bringing down the 2, I will have 2 ln of 7x plus 1, right, plus ln of tangent of x, because again, they're being multiplied. So you add, right? Anything on the bottom, you just subtract. So again, I'm going to bring down my power and do 2 steps in one, right? So this will be 1/3 2x plus 1, right? Minus, again, 4 ln, and I missed out my ln here. Let's put it here, right? So ln minus 4 ln of x minus 5 to the 4th power. Yes. So with this, now I could go ahead and solve for my dy dx. So remember, derivative of x, ln of x is just 1 over x. It doesn't change. It doesn't matter what variable it is. So derivative of ln of y is just 1 over y. So this will be 1 over y dy dx, because as we said before, now it's implicit. Once we took the natural log of both sides, now that equation became implicit. So now, again, this is just 2 over 1. So my 2 is going to be multiplied, fraction bar, my u is going to go on the bottom, 7x plus 1, multiplied by u prime. Well, u prime is just 7, right? Again, plus, right, ln of tangent. Again, fraction bar, tangent goes in the bottom because that's my u, right? We could put this as that. So that will be my u times the derivative of on the top I'm going to multiply my derivative, right? So derivative of tangent of x is just secant squared of x, right? Minus that from 1/3, so I'm going to put my 3 in the bottom. There's an imaginary 1 here, right? This will be my fraction bar. Again, 2x goes in the bottom. 2x plus 1 goes in the bottom because that's my u. Yes. My derivative of u will go on the top, which is just 2. Yes. Derivative 0. Derivative of 2x is just 1. No, 2x is just 2. Yes. I'm going to subtract that again. And look here, this should not be my power. My power already went down, so this should not be here. The 4 is right here, so disregard that. Again, so my 4 is being multiplied. My u goes in the bottom, which is just x minus 5, multiplied by the derivative of x minus 5, which is just 1. Derivative constant, 0, derivative of x is just 1. Yes? So now we can go ahead and clean this up. Right. So now 1 over y dy dx will be 2 times 7 is just 14 over 7x plus 1 plus secant squared of x over tangent of x minus 2 over 3 2x plus 1, alright, minus 4 over x minus 5. Are we done yet? No. We're solving for the derivative with respect to x. Right? We still have a 1 over y here. So here's what I'm going to do. I'm going to multiply by y on both sides. Right? Opposite of dividing is multiplying, so these y cancel out. So my dy dx now is isolated. Alright. But here's the trick. My y is being multiplied by this whole thing. Well, where's my y? My y is actually all the way up here. The original function that you started with. So I'm going to plug this in for y. So dy dx will be 7x plus 1 squared tangent of x divided by cube root of 2x plus 1 x minus 5 to the 4th. And this, which is my y, this is my y. This is going to be multiplied by this whole thing here, which is just 14 over 7x plus 1 plus secant squared of x tangent of x minus 2 over 3 2x plus 1 minus 4 x minus 5. And this will be my entire answer. So again, guys, whenever they say use log differentiation and you don't see a log in the equation, you got to take the log of both sides. And what that will do is that will make your equation now implicit and not explicit anymore.